There we go. Alright, so I just want to solve it fairly quickly. Alright, so we have a driver and we have a person. Person has a name and a wallet balance and a random number, so we already have it set up where it's just we can create a couple of persons, right? So now we just need to write a queue. So we have our queue class, and the queue will have a person head and a person tail, because we need to be able to access the front and back of the list. Then we'll have our public queue constructor. We'll say this dot head is equal to null, this dot tail is equal to null. Then we will have a public void enqueue, which will take a person as a parameter, and we want to put that person into the queue, so they're always going to go in at the tail, correct? So we'll say if tail is equal to null, that means we're dealing with the empty list. So if tail is equal to null, we'll just say tail is equal to p and be done with it. And I like to say this dot and this dot, just like to be explicit. Otherwise, if tail's not equal to null, we need to set person equal to our new guy. Now, what we're going to go ahead, just to make this act probably in the easiest possible way, instead of putting a person inside of a node, we'll just go ahead and give person. Well, do I want to do that? Let's just put it inside of a node. So I'll create a new class, node. And node's going to have a private person payload. And it will have a private node next node and a private node prev node.
Couldn't you just do that all inside a person?
You could. That's what I was about to do before. But instead, I'm just going to keep the thing separate.
I see.
So we'll say public node. We'll take in a person payload. And we'll say this dot payload is equal to payload. This dot next node is equal to null. This dot previous node is equal to null. Then we want to go ahead and give ourselves getters and setters. So source, generate getters and setters. We want to have a set and get next node. We want to have just a get payload. And we want to have a set and get previous node. So generate all those. So that's node. So now we go back to queue. And the very first thing we'll do is now our head and tail are no longer persons, now it's node. Head and tail point to the node at the front or the end. So we'll say node n is equal to new node p, passing it the person n, because a node takes a payload of a person. If tail is equal to null, this dot tail is equal to n instead of p. Otherwise, we need to add person to the end of the, well, we need to add n to the end. So we're going to say n dot set previous node to tail, this dot tail. And then we'll say tail is equal to n. Actually, we need to say tail dot this dot tail dot set next node equal to n, and then tail is equal to n. Okay, so we'll set our new guy's previous node equal to the current tail. Then we'll set the current tail's next node equal to our new guy, and then set tail equal to, then we'll set tail equal to n. So,
In my text?
no.
Why wasn't there class today?
Oh, I'm recording it right now, the lecture.
Oh.
It's a really funny story if you want to wait a few minutes. We're doing Bible study too. You want to come? Oh, well, I'll tell it. I guess it's going to be on camera. I had a web chat this morning, and my supplements I'm on, all these pills, make me a little nauseous, and I sneezed during the web chat, and I threw up all over myself. I threw all over myself, and the funny thing, it was during the web chat, but luckily I was sharing a PowerPoint presentation at the time but I just kept going. The damage was done, and we still had like another 25 minutes to get through the stuff. So I just
Did you go home and change?
Yeah, that's what I did. So now I'm basically recording the solution to the homework right now, and then I'll go over what's going to be on the midterm, all in a video, and then I'll upload the video for everybody. It'll be a short thing, so we'll probably be maybe only another like 10 minutes or something.
Wow, that's funny.
Then we have lunch and Bible study to come.
You know how it started 175 like halfway through this semester? We just got a test on it, and I only got 2 problems wrong. I got 94 on it.
Good.
Yeah, it's pretty good.
So you want to come to Bible study? Got something better to do?
Yeah.
Like what?
I have to figure out what I'm doing, if I can stay here on campus during spring break. Like, just so I have, like, food access, because they turn off your cards.
Oh, I see. All right.
I'll see you.
Later. All right.
So you coughed.
I'm recording here. I'm recording a lecture for the class I missed. All right, so node n is equal to new node. If this dot tail is equal to null, just set it to tail. Otherwise, we're going to set our new guy's previous node equal to tail, tail's next node equal to our new guy, and then set tail equal to our new guy. So that is NQ. And then we need to have a public, do we want to return a person? DQ. We always DQ from the front, so we'll just say node to return is equal to this dot head if node to return is equal to null. Return null, else return node to return dot get payload. Make sense? But before we do that, if it was not equal to null, we need to set let's see, this dot head dot get next node dot set previous node to null. So we can either set the next guy's previous node to nothing, and then set this dot head equal to this dot head dot get next node. And then finally we can say node to return dot set next node to null. That'll detach it completely from our queue. Okay, so when we're taking something off, we go to the head, we get the head's next node. Well, we need to make sure that's not null. So if this dot head dot get next node is not equal to null, that means it's not the one list. If it's not equal to null, then set the next node's previous node equal to null. And then we'll set head equal to head's next node, which might be null, that's fine. So yeah, the rest of it's fine. This line will just work sometimes if we're dealing with something that's not the one list. All right, so that should be our queue. DQ, NQ. So now we can go back out to driver, and what we were supposed to do, 100 people. Is that right?
Yeah.
So we'll have a little for loop for int I is equal to 0, I is less than 100, I plus plus. We'll have a linked, now we're going to have a queue. My queue is equal to new queue. All right. And then each time through, we're going to say my queue dot nq new person space concatenated with I. So that'll add 100 guys to the queue. All right. And since we know there's 100 guys in there, we'll say for int I is equal to 0, I is less than.
Can you reuse I?
Huh?
Can you reuse I?
Yeah, because it's a local variable to this for loop.
Okay.
So I is less than 100, I plus plus. We'll say my queue dot dq dot display. And that should display our 100 random people.
And then your queue should be empty.
Queue should be empty afterwards.
So to double check that, I just did the myQ.dq.display again outside of the loop.
No pointer exception. Line 14, that's this one, so that's DQ. Oh, because we potentially could get a null coming out of this.
Throws exception.
So let's just have driver throw the exception. Actually, we'll just do a try catch in here, it's fine. We will try to do this. Catch, exception, E. Close it. So we have a problem in our DQ. DQ, node to return is head. Oh wait, we're never dealing with head here in NQ. That's a problem. So NQ, node N, if tail is null, then this dot tail is equal to N, and this dot head is equal to N. So head and tail both point to the same place in that case. Otherwise, yeah, that should fix it. We never actually set head to anything. So here's all my person 0 through person 99, $8 on me, blah, blah, blah. Make sense?
Yep.
All right, so that's our queue example. All right, then review for the midterm. Okay, so let's see, where did this class start? Well, actually, let's just go through all this stuff. So, I mean, these would be things that are fair game. How do human beings solve problems? Machine language, low level, high level, procedural, object-oriented, functional languages, strongly typed, loosely typed. You know, I'll probably pull one question out of, you know, kind of how did we get where we are today? History of programming languages, things like that. Probably won't ask a question about Java's platform independence or anything, or virtual machines. certainly understand what variables are. I might ask you a question about primitive types, like what's a primitive type, or list the primitive types, that kind of stuff. Potentially could ask you questions involving the primitive types, like why do we have so many ways of holding integers? Positive, like the Y2K issue. Memory, we inherited all of our primitive types from the C programming language, which existed during the Y2K time period where memory used to be at a premium. So we used to have to use variables of the kind of the smallest footprint that would hold the kind of information we needed to hold.
So it was limited?
Yeah, memory was limited because it was expensive. Certainly converting bits and bytes and that kind of stuff would be fair. The concept of variable scoping and how variables resolve to their most local definition. What's a Boolean expression? Be able to use the scanner object to read stuff in from the user. Understand the different loops and what kind of problems they apply themselves to or lend themselves to. Again, variable scope. What's the new keyword do in terms of bringing back a memory address and how pointers work? I suppose I might ask a polymorphism question, but I kind of overkill that, so probably not. What's a method? So here's like an example of pointers, that kind of stuff. So be able to understand pointers. Instance methods versus class methods. String concatenation, being able to use index of and char at kind of for various types of problems. Continue and break commands. Continue skips to the next iteration of a loop. Break breaks you out of a loop. All sorts of problems dealing with string parsing, breaking a string up into other pieces. Arrays, how they work in terms of being contiguous memory and how they're considered to be fast versus linked lists, which are considered to be relatively slow but very memory efficient. Passing by value versus passing by address. We're passing stuff to a method. Again, this is all pointer stuff. Compare to method for comparing strings lexicographically, as opposed to comparing strings for to see if the pointers are the same. Recursion would be fair game. How does merge sort work would be fair game. Certainly this keyword and the super keyword, how they work.
That's pretty much where we started.
Yep. So now we have, so that would be all the stuff leading up to what you should already know. Here's more variable environments. This is variable scoping. Public, private, protected. What's the difference? Specifically, when to use public, when to use private. Accessor methods and mutator methods, getters and setters. Some of the issues with arrays compared to linked lists. Arrays are fixed in size and have to be right next to each other in memory, that kind of stuff. How do linked lists work, both singly and doubly linked lists? Is that the last thing I have in this slide set?
Yeah, you started saying more stuff, but we didn't really add it. Like, I have stuff about GitHub, and actually there should be more about stacks in there.
That's what I was thinking.
Yeah, and reverse Polish notation had a slide.
Yeah. Well, here, I'll just kind of create another slide. So, certainly, doubly linked lists.
That's what we had for stacks.
Okay. So here. So we got doubly linked list. pros and cons, stacks in terms of push, pop, peak. This is a LIFO Q, Q, NQ, DQ. This is a FIFO Q. And stacks and queues are special versions of linked lists. When would we use all these things? So understand how linked list works, how stacks and queues work, how next and previous pointers work. Certainly I might give you a snippet of code and ask you to write just a couple of lines of code that might insert a node in between two other nodes or something like that to show that you can hook up the pointers.
So are we going to have to write multiple classes, or?
There'll probably be one programming question that has you write, maybe like something that requires maybe two classes. The other ones might be more like programming snippets where I give you some stuff, assume this exists and go ahead and write the couple of things that accomplish something. Okay? But I would say that any coding will probably be very dependent on your knowledge of pointers. Understand how to connect pointers to other pointers and move things around that way. Prove that you understand memory. That kind of stuff.
Drawing pictures?
Drawing pictures, yes.
Let's draw pictures on the exam.
I wouldn't ask you anything about Towers of Hanoi. It's just an implementation of a stack. So I would say that's probably high level it. Probably be about 10 questions on it. Probably 2 or 3 of them programming. Out of that, maybe one of them would be somewhat, a substantial programming question. The other 2 might be more of a, write the code to accomplish this little thing, that type of thing.
Push your exam to GitHub.
That makes sense? There could be a GitHub question, I suppose. Kind of just what is GitHub and how does Git and GitHub. Cool?
Yep.
All right. Anything else that you think needs to be on here? Or should I just upload it?
I think it should be good.
All right.